Hello students, welcome to Shri classes. This is with respect to applications of trigonometry chapter 9, lecture number 3, level 2 RDS numericals. Probably about few sums I would like to solve it, and let us see whether we are able to solve those numericals or not. Here the problem goes like this. Example number 32, level 2 D Sharma. There is a tower AB on which there is a flagstaff of height h. The angle of elevation of bottom of the flagstaff is alpha and angle of elevation of top of the flagstaff is beta. In this case, we need to prove that the height of the tower, what is the height of the tower? AB, which is y here. Prove that height of the tower equals h tan alpha divided by tan beta minus tan alpha. So can I mention over here height of the tower as y over here? So I can put something like this, equals y equals. This makes sense, isn't it? Okay. So we need to prove over here y equals h tan alpha divided by tan beta minus tan alpha. So let us see. This is a right angle triangle first. Everything, see here, y should be expressed in terms of h and tan of alpha and beta. That is our objective. In triangle AOB, tan of alpha equals y by x. Y by x. What is this x? X is the distance from the foot of the tower to the point of observation. So tan alpha equals y divided by x. Okay. Tan alpha equals y divided by x here. So what we should do from here? Anything? X is equal to, let's see here. If anything is required, we'll take it, or I'll say x equals y divided by tan alpha. Why I am doing this, I don't know. Let's keep this 1. Now in triangle AOC, tan of beta equals y plus h divided by x. So if I substitute the value of x by y by tan alpha, then finally I should be able to separate out y and try to get the answer, isn't it? So let this be 2 here. Now substituting x equals y divided by tan alpha into 2. We are substituting here. So what we get is tan beta equals y plus h divided by x. X is equal to y divided by tan alpha. So this can be written as, here we'll solve, tan beta equals, tan alpha goes up, y plus h into tan alpha divided by y. I have taken this tan alpha up. So multiply, cross multiplication, y tan beta equals y tan alpha plus h tan alpha. Now transpose this side, and what is that I require? Y is to be taken common, beta minus alpha is there, so I'll retain this here and this I'll bring this side. Y tan beta minus y tan alpha equals h tan alpha. Okay. So what is common? Y into bracket tan beta minus tan alpha equals h tan alpha. Therefore, height of the tower y equals h tan alpha divided by tan beta minus tan alpha. H tan alpha by tan beta minus tan alpha. Hence proved. I hope you are able to understand here. This diagram is given actually R D Sharma, and we use the diagram to prove that height of the tower is equal to S tan alpha by tan beta minus tan alpha. Not much difficult. One very tricky thing here is I could have transposed this side and taken H tan alpha to minus tan alpha, and still I could have found out the value of y. But remember, we require positive H tan alpha, and here it should be beta minus alpha, tan beta minus tan alpha, and therefore in order to get a tan beta minus tan alpha, we transposed y tan alpha this side, and finally took common y, and once again transposed to get the value of y as H tan alpha by tan beta minus tan alpha. Make a note of this. Example 33. Angles of elevation of top of a tower from 2 points at a distances a and b meters from the base and in the same straight line with it are complementary. So the angles of elevations of the tower from 2 points at a distances of a and b are complementary to each other. Prove that the height of the tower is AB. So height of the tower is AB. Prove that height of the tower is under root of AB meters. That means let AB be the tower with height h, and for at a distance, if we the angle of elevation of the top of the tower at a distance of from A, that is, see the angle of elevation of top of the tower when viewed from A meters from the base of the tower, that is from point C, it is theta, and here it is 90 minus theta, because these two angles of elevations when viewed from A meters and B meters, that is from here, these two are complementary to each other. In this case we have to prove that height is equal to under root of AB. So let us solve this on the board. This is the diagram given. So this is right angle. In triangle ACB, tan theta equals H by A. In triangle ADB, tan 90 minus theta, tan of 90 minus theta equals H by B. H by B. Tan 90 minus theta is cot theta equals H by B. This is 2. So from 1 and 2, multiplying 1 and 2, 1 into 2 implies tan theta into cot theta equals H by A into H by B. H by A into H by B. Tan into cot is 1, which equals H square by AB, implies H equals or H square equals AB, implies H equals plus or minus under root of AB will be there, but these are the heights which are basically the distances. We consider only the positive value, H equals under root of AB. Note down. Example 35. If the angle of elevation of a cloud from a point h meters above the lake is alpha and the angle of depression of its reflection in the lake is beta, prove that the height of the cloud is given by h into tan beta plus tan alpha, the whole divided by tan beta minus tan alpha. It is NCERT exemplar and also had appeared I think in previous years also. So let us try to solve this on the board. Here the diagram we will draw. Lake here. From height h above the lake, we are observing a cloud. The angle of elevation of the cloud from height h is alpha. Now the angle of depression of this cloud or the angle of depression of the image of this cloud in the lake is beta. The angle of depression of the image of the cloud, is it the image or what is given? Angle of depression of reflection in the lake is beta. That means we should get the reflection of this cloud in this lake, and when it is observed from this height h, the angle of depression is beta. In order to find the reflection of this into this lake, we know the object distance should be equal to the image distance, and therefore at the same height h, let h be the height of the capital H be the height of the cloud above the surface of the lake, and below also it will be same h where the reflection of this cloud is formed. So let me draw that one here. So here at this distance the image is formed, something like this. This is the image of the cloud or the reflection of the cloud. At what distance? Same, h above, h below. Now let us draw the line of sight, angle of depression. So angle of depression of this reflection when observed from h meters above the ground is beta. Yeah, this angle of depression is beta. In this case, what is that we need to prove here is height of the cloud above the surface, h equals, to prove I'll write, to prove h equals small h into tan beta, small h into tan beta minus tan alpha we need to prove that h equals h into tan alpha minus tan beta, the whole divided by tan beta minus tan alpha. Wrong, just a moment. We need to prove that height of the cloud above the lake is h into tan beta plus tan alpha, tan beta plus tan alpha, the whole divided by tan beta minus tan alpha minus tan alpha. This is what is to be proved over here. So here it's interesting. Let me mark this ABCD. This PA B, AB is of height h, and this BC and D, CD is the height of the cloud above the lake, that is capital H. This also will mark it A, B, C, D, E and F. So there are two triangles here, alpha and beta. You can observe in this triangle alpha is there and in this triangle beta is there. By taking tan ratios in both the triangles, we should be able to prove, isn't it? Okay, now very important thing here is in this triangle BED, and in triangle BEF, BE is common. So if I take tan alpha, this by this will be there, and if I take tan beta, this EF by BE will be there. Being BE is the common, if I equate that, I should be able to get the value of H here. So let us solve this. One more important information here, I need to know the hypotenuse in both the triangles. The hypotenuse in this triangle is DE, that is from here to here, which I am writing with red letters. Where is the red ink pen? Yeah, here. See the hypotenuse of this triangle. This one is capital H minus H, and from here to here is the hypotenuse. Here I'll write from here to here, this is the hypotenuse of the other triangle. So how do you calculate this one? From here to here, from the top surface of the lake to here, this is H here. I'll write here also. This is H and this is H. So H plus H is from here to here, h plus h. So I have got h plus h as one hypotenuse and capital H minus small h as the other hypotenuse. I think this is very clear for you. Now taking tan alpha tan beta and equating to b, you will get the answer, which is very simple. So let us solve this one over here. In triangle BDE, or I'll take directly tan alpha is equal to DE by BE, and therefore tan alpha equals h minus h divided by BE, h minus h divided by BE, and therefore BE is equal to h minus h divided by tan alpha. Mark this as 1. Now tan beta will take. Tan beta equals EF by BE. So tan beta equals, what is EF? EF is h plus h divided by BE. Therefore BE equals h plus h divided by tan beta. Mark this as 2. So from 1 and 2, BE equals h minus h by tan alpha, BE equals h plus h by tan beta. Equate these two and extract capital H from this one. That should give you the result. So from 1 and 2, BE equals h minus h by tan alpha, h minus h by tan alpha, and also BE is equal to h plus h by tan beta, h plus h by tan beta. Cross multiply h minus h into tan beta equals h plus h into tan alpha, h tan beta minus h tan beta equals capital H tan alpha plus small h tan alpha. H is to be transposed now. Here one h is there, here one h. That means h tan beta, h tan alpha is there. Okay. So what should we do now? We require h equals tan beta plus tan alpha is there. H equals tan beta plus tan alpha and tan beta minus tan alpha. So if I multiply this h by tan beta minus tan alpha, h tan beta minus h tan alpha should be there, and therefore I will retain this as it is and transpose this to this side and transpose this to that side. Now it is very clear. So h tan beta minus h tan alpha equals, transpose that this, h tan beta plus h tan alpha. Take common h into bracket, tan beta minus tan alpha equals, h is common, small h into bracket, tan beta plus tan alpha, and therefore capital H equals h into bracket tan beta plus tan alpha, the whole divided by tan beta minus tan alpha. Is it the one which we need to prove? H tan beta plus tan alpha divided by tan beta minus tan alpha. Perfectly alright, and hence proved. And therefore height of the tower is, finally you write, therefore height of the tower is equal to capital H equals h into bracket tan beta plus tan alpha divided by tan beta minus tan alpha. Hence proved. See dear students, you will get one numerical also where you will be given this h and we need to find out capital H, and alpha and beta also will be given to you. Always it is preferable, according to me, okay, because in my old our all previous year students also felt that this is much easier. What is much easier? Taking this h, either small h or capital H, as the height of the cloud from the lake. Height of the cloud from the lake, taking either capital H or small h in solving the numerical. But in this case here, already the textbook says this is small h here, and therefore I am considering height of the cloud from the top of the lake surface is capital H over here. Okay, that's the only difference. In solving the numerical, I'll consider this height will be given some 60 meter, 50 meter, etc. So this I'll be taking small h. Why I'm doing that way is, in some of the solutions and all, D Sharma and all, they take this as a small h, which EC is equal to small h, and this part DE as a capital H. So height of the cloud will be this small h plus this capital H gives you height of the cloud, or something different, something like this they will give you. I will be taking always height of the cloud above the lake surface as either small h or capital H. That is my this thing. So in that case, what happens is, this part, opposite side in this triangle will be capital H minus this height, and opposite side EF in this triangle is capital H plus this height. So H plus H, H minus H are the components which I will be retaining. I hope you understood. Make a note of this. Next sum, example number 36 here. It is the continuation of same problem, not continuation, similar type. Example 36, the angle of elevation of a cloud from a point 60 meter above the lake is 30 degrees and the angle of depression of the reflection of the cloud in the lake is 60 degrees. Find the height of the cloud. So as I said, 60 meter above the lake is the point of observation. From there, the angle of elevation is 30 degree, angle of depression of the reflection of the cloud is 60 degree. In that case, find the height of the cloud. CBSE 2010. Let's solve this now. Same diagram. We are observing the angle of elevation of the cloud from this point where this height is given as 60 meter. 60 meter. So I am not using this small h here. I can simply say this is 60 meter. The angle of elevation observed from a height 60 meter above the lake, the angle of elevation of the cloud observed from a height 60 meter above the lake is 30 degrees. So this alpha here is 30 degrees. And the angle of depression of the reflection of the cloud observed is the angle of elevation of the cloud from a point 60 meter above the lake is 30 degree and angle of depression of the reflection of the cloud is lake is 60 degrees. This is 60 degrees. In this case, we need to find out the height of the cloud. That is the question. Little bit changes I am doing. Look here. This h is 60. Let this h be height of the cloud from the lake is what is a question mark. This is a question mark. This is, here it is h minus 60. From here to here, see, from here to here it is h. This is 60 and therefore from here to here it is h plus 60 and therefore this distance h plus h is nothing but h plus 60. I hope you are able to understand this here. H plus 60 meters. So dear students, in a triangle BED I have got h minus 60 as the opposite side. In triangle BEF, the opposite side EF is in terms of h plus 60. If capital H is the height of the cloud above the lake surface, in that case, in the two triangles, I am getting h minus 60 as the opposite side and h plus 60 as one more opposite side. BE is common. If I equate tan 30 and tan 60 with respect to BE, I should be able to get the value of h here. Same process I will continue. But only thing, this is the new diagram now. And therefore, this 60 meter is given to you. And therefore, let us see how to find out. Now, considering in triangle BED, tan 30 is DE by BE. I think ink is to be filled for all the pens. DE by BE, and DE is h minus 60 divided by BE. What is tan 30? 1 by root 3 equals h minus 60 divided by BE, and therefore I'll write BE equals h minus 60 into root 3. Mark this 1. Next, in triangle BEF, tan 60 is opposite side EF divided by adjacent side BE. Tan 60 degree equals EF by BE, which equals, what is EF? H plus 60, capital H plus 60 divided by BE. What is tan 60? Root 3 equals H plus 60 divided by BE, implies BE equals H plus 60 divided by root 3. Mark this as 2. This is 1, this is 2. Now let us see what we have to do. From 1 and 2, BE equals this one, BE equals this. Therefore, these two I am equating. From 1 and 2, this is 1, this is 2. H minus 60 times root 3, 60 times root 3 equals H plus 60 divided by root 3. Root 3 into root 3, 3. So 3 times capital H minus 60 equals capital H plus 60. So 3H minus 180 equals H plus 60. Transpose 3H minus H equals 60 plus 180, which equals 240. So 2H equals 240, implies H equals 240 divided by 2, which is 120 meter. I think we got the answer. H equals 120 meter. Therefore, height of the cloud from the surface of the lake is 120 meters above the surface of the cloud. Let me check the answer now. Yes, it is 120 meter. So, did you understand, dear students? See, it is important. If I take capital H as the height of the cloud, then the reflection will also be below H, capital H only. So, in this case, in this triangle, from here to here H, from here to here 60. Therefore, opposite side is H plus 60, which is written, because I am interested to know the opposite side in this triangle, because I would like to take tan 60 ratio. Similarly, in this triangle, if this is 60, EC also will be 60, and if the height of the cloud is H, then this opposite side ED equals from here to here minus here to here. From here to here it is h, from here to here 60, and therefore from here to here equals h minus 60. So h minus 60 opposite side, h plus 60 opposite side. In these two triangles where BE is common, take tan 30, tan 60, equate to BE, you will get the height of the cloud. Simple. Make a note of this. Example 37, NCERT example problem. A round balloon of radius r subtends an angle alpha at the eye of the observer, while the angle of elevation of its center is beta. Prove that the height of the center of the balloon is r sin beta cosec alpha by 2. Let me consider the center of the balloon, height of the center of the balloon from the ground as h, small h. Let us see how to solve this on the board. Consider this balloon and the radius r, and see, this is a ground here. And this be height h, small h. H here. That is the prove that height of the center of the balloon is something is given, we have to prove that. Now this is the height of the center of the balloon. Thing is, this balloon subtends angle alpha at the observer's eye. Suppose I will consider the observer's eye is here, something like this, and this balloon subtends angle alpha at this eye, meaning I need to draw here the tangents from this observer's eye. The tangents I require, I hope I am drawing rightly. So this is one tangent to the circle and another tangent here. So I can consider this way. I need to adjust a little bit. I think I should be able to draw properly. Okay. So the angle subtended by the balloon at the observer's eye is alpha. This angle is alpha. Let me draw the radius. Radii and the tangents are perpendicular to each other. This is 90 degree, and here also this also is 90 degree, because the radius r is the radius of the balloon, and the balloon subtends angle alpha at the observer's eye. Now another question is, he has given one more information. The angle of elevation of center of the balloon is beta. The line of sight is from this point to the center. Let this center be O, and this is the point P. So OP, let us join it, and that is the line of sight of center. So OP is the center, and the angle of elevation of center of the balloon is this angle. This is beta. This is given to you. In this situation, we need to prove that height of the center of the balloon, that is to prove that H equals r sin beta into cosec alpha by 2. Cosec alpha by 2. This is what is to be proved. Simple, not much of a problem. Let me identify this as OP. This is A, B, and this is also right angle C. ABC. Okay, I hope you have understood the diagram here. Now, this is a radius and OB is also radius, and therefore here, this OP will be the angular bisector of angle P. That means if the whole angle is alpha, angle APO equals angle OPB equals alpha by 2. So this angle is alpha by 2, and similarly this angle is alpha by 2. This you learn in circles chapter also, tangents and circles. You will learn that the tangents drawn from an external angle are equally inclined to the line segment joining the center to the external point. कुछ आ रहा है समझ में? नहीं आ रहा है ना? The tangents drawn from an external point to a circle are equally inclined to the line segment joining the external point to the center. The tangents drawn to the circle are equally inclined to a line segment joining the external point to the center of the circle. So, for OP, AP and BP are equally inclined, meaning if angle subtended by the balloon is alpha, that is angle APB, then angle OPA equals angle OPB equals alpha by 2. I hope that you have understood. Now, what we'll do here is, in order to find H, I require triangle OPC. In this triangle, if I take the ratio of H by OP, it is sine of beta. I hope you are understanding. Sine beta equals OC by OP. So can I do that first? In triangle OPC, the bigger triangle OPC, sine of beta equals OC by OP. Therefore, sine beta equals, what is OC? H, height of the center, H divided by OP. You got it? H divided by OP. Mark it 1. Why did I take this one? Now, if I replace OP in terms of R, then H can be expressed in terms of R and sine beta, and also in terms of sine alpha by 2. So what we'll do here is, in triangle OAP, in this triangle, what is OP? How do you establish the relationship between OP and R? With respect to alpha by 2, OA is opposite side, OP is hypotenuse, AP is adjacent side. So in triangle OAP, for your information, I am writing this is hypotenuse OP, OA is opposite side, and PA is adjacent side, ADJ side. Because this is a right triangle, opposite to right triangle is hypotenuse, and adjacent to alpha by 2 is adjacent side, and opposite to reference angle alpha by 2 is R. So I think you are able to understand, in triangle, right triangle OAP, acute angle is alpha by 2. If acute angle is alpha by 2, opposite to alpha by 2 is opposite side OA, and adjacent to this angle is adjacent side. Let me take the relation to establish, or the relation that contains R and OP. R and OP, opposite and hypotenuse. So can I take sine alpha by 2 in triangle OAP? So in triangle OAP, once again I'll take sine of alpha by 2. Sine of alpha by 2 equals opposite by hypotenuse, OA by OP. OA by OP. What is OA? R, radius, R divided by OP, and therefore OP equals R divided by OP equals R divided by sine alpha by 2. Therefore OP equals R. 1 by sine is cosec, R into cosec alpha by 2. Mark this as 2. Substitute 2 in 1. Substituting 2 in 1, we get, what is that we get? Substituting 2 in 1, sine beta equals h by OP, h by OP, which equals h divided by OP is R cosec alpha by 2, R into cosec alpha by 2. Therefore you find h, no, implies h equals sine beta into R cosec alpha by 2, sine beta into R into cosec alpha by 2 implies h equals, what is to be proved? R sine beta into cosec alpha by 2. R you write in the first beginning, R into sine beta into cosec alpha by 2. This is what we proved here. Hence proved. So I hope you are able to understand this. Very important thing is, it is simple. If you want h here, height h is the height of center of the balloon. You take the ratio of sine beta h divided by OP. In order to get the value of OP in terms of R and alpha by 2, apply once again or take once again T ratios in right triangle OAP. It is very confusing. Now also you are getting confused. You are not understanding. In triangle OAP, which is the hypotenuse, which is the adjacent, and which is the opposite side. You are getting confused, I know that. And therefore once again I will explain. In right triangle OAP, opposite to right triangle is hypotenuse, which I am interested to find out. Alpha by 2 is the reference angle. Opposite to alpha by 2 reference angle is the opposite side. So if this is opposite side, if this is hypotenuse, and this will be adjacent side. Very simple. If I locate hypotenuse and opposite side, definitely adjacent side is the third side. In this case, I'll take the ratio of sine alpha by 2, which is opposite by hypotenuse, R by OP. This is what we have written in triangle OAP. This is what it is, R by OP. Find OP from this equation, that is OP equals R cosec alpha by 2. And already in the bigger triangle we have taken sine beta is equal to h divided by OP, which is in the 1. So substituting 2 in 1, we should be able to express h in terms of sine beta cosec alpha by 2 and the radius. So this is how we can solve this problem. Once of course it had appeared many times in your tests also, this will come, and this is the example problem of example 37. So make a note of this one. Example 40. The angle of elevation of the top of the tower from a point due south of the tower is alpha, and from a B which is due east of the tower is beta. if AB equals D, then show that the height of the tower is D divided by under root of cot square alpha plus cot square beta. This is a three-dimensional diagram. This problem requires the diagram which is a three-dimensional diagram. So let me explain to you something like this. Here, rough diagram I will draw and then I will convert it to the final diagram. So something like this: north here, south here, east and west, and on this top there is a tower. There is a tower here of h height, and this is how the diagram looks like. That means this tower is situated on the ground, something like this. आया आपको समझ में अभी? This is a plain ground on which the tower is standing, and this side is east, this side is west, this side is south, and this is north, south, east, west. This is north, south, east, west, and this is the tower, how it is looking on a plane. This is a tower on a plane which is standing like this. I hope with this you should be able to visualize it. Points, let us consider the angle of elevation of the top of the tower from a point due south, from a point A, from a point A due south. That means a point due south. Where is south here? Here. So I'll consider one point here which is A. From this point, the angle of elevation of this tower is alpha, and a point due south of the tower is alpha, and from point B due east, from point B due east means towards east, point B, the angle of elevation of this top of the tower from this point B is beta, and AB is given as this D. AB is given as D. In this case, show that the height of the tower is D divided by under root of cot square alpha plus cot square beta. So the same diagram I am drawing once again in a bigger scale so that you will understand very clearly. So let me first of all draw the tower here of height h, and yes, north, south, east and west. So this is x-axis, this is y-axis, this is z-axis, something like that you can visualize. Now I'll pick up 2 points. Point A is due south, means towards south. This is point A, and point B is due east, and therefore the point is B here. From here, if I look at the top of the tower, which is height h, the angle of elevation of top of the tower from this point is alpha. So I will join these two, A and the top of the tower. I will join. This angle equals alpha. From point B, if I look at the top of the tower, then the angle of elevation is beta here. So this is angle of elevation beta viewed from the point B due east. Is it right? Due east. Now also he has given the distance between these 2 points A and B is d, small d. So that also I will join it here. This is small d. Okay. In this case we have to prove that small h equals d divided by under root of cot square alpha plus cot square beta. This is what is to be proved. I hope this you have understood the diagram. This I'll erase now. Rough diagram is important to mark the points A and B and D actually. That is what I drew that small diagram. Dear students, it is simple here. If you want to find out the height h over here, what should we do here? D divided by this under root of. So let me mark AB, and this is O here, A, B and C. How should we find out the height h is the question now. Can we do one thing? Let us find out in triangle OAB, OA square plus OB square equals D square. Then let me express OA in terms of h and alpha considering right triangle AOC. This is right triangle. Also let me express OB in terms of h and beta. In that case, OA I know in terms of h and alpha, OB I know in terms of h and beta. Therefore, OA square plus OB square is equal to D square. Why OA square plus OB square is equal to D square? See here, this is right angle. This is right angle. Triangle AOB is a right triangle. All these are three-dimensional. I hope you are able to understand. This is one plane here, isn't it? Plane means plane surface. So first I'll write in right triangle OAB. Proof I am writing now. In right triangle OAB, OA square plus OB square equals AB square. AB square equals OA square plus OB square by Pythagoras theorem. What is AB square? D square. AB is equal to D here. D square equals OA square plus OB square. Mark this 1. If I substitute OA and OB in terms of h and alpha and h and beta, my job is done. Now in triangle OAC, okay, look here, this is a right triangle. In right triangle I'll write, in right triangle OAC, right triangle OAC, h by OA is tan alpha. Tan alpha equals h by OA, implies OA equals h by tan alpha. Mark this 2. Similarly, in right triangle OBC, right angle at O, h and OB, can you find out the relation? H divided by OB, opposite by adjacent side gives tan beta. Tan beta equals h divided by OB. Implies OB equals h divided by tan beta, and this mark it as 3 here. Substitute OA and OB in equation 1. Substituting OA and OB in equation 1, we get, what is that we get? Let us see. D square equals OA square, OA is h by tan alpha, h by tan alpha the whole square, plus OB square is h by tan beta, h by tan beta the whole square. This is from 2 and 3. 2 and 3. Now this also can be written as d square equals h square by tan square alpha plus h square by tan square beta, which is h square take common. If I take h square common, 1 by tan square alpha divided by 1 by tan square beta, which is again h square into bracket. What is 1 by tan square alpha? Cot square alpha. Plus what is 1 by tan square beta? Cot square beta. Cot square beta. So finally we got d square equals h square into cot square alpha plus cot square beta. So therefore h square equals, h square equals d square the whole divided by cot square alpha plus cot square beta. Transposes this h square equals d square divided by cot square alpha plus cot square beta, implies h equals, plus or minus will be there, but here only plus I am taking, d square divided by cot square alpha plus cot square beta. Out of this d square comes out of the root as d, and therefore, or you can say under root of d square divided by under root of this one. So one more step I will write for your information. Under root of d square divided by under root of cot square alpha plus cot square beta. What is under root of d square? D, which equals d the whole divided by under root of cot square alpha plus cot square beta, and therefore finally h equals d divided by under root of cot square alpha plus cot square beta, hence proved. I hope you have understood what I did. Once again I will explain it. See here, the angle of elevation of the top of the tower from point A due south. In this diagram, north, south, east, west. You understood? In this case, a point due south is from the origin, due south is point A, and from the origin due east is point B. From point A, if you look at the tower which is OC of height h, the angle of elevation of top of the tower from point A is alpha, and the angle of elevation of top of the tower from point B is beta. So this angle is alpha, this angle is beta. You got it? And it is given that AB is D. So here we can see three right triangles. Those three right triangles are, where is the red ink pen? The three right triangles are OAC, right angled at this point, OAB, right angled at this point, and OBC. Three right triangles are there because this is a tower, and three right triangles. We know that in right triangle OAB, OA square plus OB square equals AB square, and this is written as our first equation. Now I want to know the values of OA and OB. In right triangle OAC, opposite by adjacent side is equal to tan of alpha, and therefore you get the value of OA. OA equals h by tan alpha, or simply h into cot alpha also you can write anyway. Similarly, OB equals h tan beta. OB equal h by tan beta, OB equals h by tan beta, or h cot beta also you can write, no problem. So once if you know the OA and OB values, you substitute over here. AB square is D square is equal to what is OA square? H square cot square alpha plus h square cot square beta. H square take common, cot square alpha plus cot square beta. H equals D square divided by cot square alpha plus cot square beta, and H is equal to under root of D square by so and so. Finally we were able to prove this one. So this is quite simple, but you must understand the diagram over here, which is a 3-dimensional diagram. Hence I have taken this sum. So make a note of this one. Yes students, I took some of the numericals from D Sharma, and there are few more numericals. One numerical is on a 3-dimensional diagram, something like this. I will read that also. The elevation of a tower at station A, due north of it is alpha, and at a station B, due west of A is beta. Prove that the height of the tower is AB sin alpha into sin beta divided by sin square alpha minus sin square beta. So this is on similar grounds. Draw the same diagram, north, east, south, west, but the points are different here. A is due north and B is due west. From there you make the angles of elevations and select the suitable right triangles and apply the Pythagoras theorem and try to solve this. Now so these are some of the numericals which I have taken from D Sharma. These are also some example of numericals. With this I think you should be able to solve any kind of problem that we can expect from applications of trigonometry. You have to practice a lot, and most of these numericals, especially in the applications of trigonometry, are the word problems, and hence you should have a very good patience for reading the paragraphs, for reading the problems and converting them into a problem statements. That means problem statements need to be converted to mathematical expressions, for which you can make use of rough space also in the beginning if you have a confusion, and then final diagram should be made and solved. All these applications of trigonometry, you must draw a proper diagram. Without proper diagrams you should not solve also, and it is not possible to solve also. So with this we'll end this chapter, that is chapter number 9, applications of trigonometry, which I have covered in almost all respects, including D Sharma numericals, which are quite critical, and exemplar problems. So please try yourself few more problems. If any doubt, then you can get back to me. So thank you very much for watching, and we'll see you in the next lecture with the new chapter. Thank you very much for watching.